Welcome to the Crazy Hat Chemist. So another video here on electrochemistry. So let's get moving. Bam! So today we are talking about balancing electrochemical reactions on number 9. Okay, we're going to balance the redox equation below. And here it is. It's aluminum plus water gives aluminum hydroxide with a 1- charge. Okay, just like before, this is a complex ion like on the previous balancing equations number 8 plus hydrogen. So the first thing that we need to do is assign oxidation numbers to all elements. Now, if you have an element in its standard state, it's a 0. That's why the aluminum is a 0. Hydrogen is a +1, oxygen is a -2, 1 plus, 2 minus, there those are. Then we have the aluminum hydroxide 4 with a complex ion there, right? It's a cation and an anion combined that does not have a net charge of 0, but does have a charge of either a positive or a negative. In this case, it's a negative charge. Okay, the oxygen is going to be a -2, the hydrogen is going to be a +1, and then it has a net charge of -1. Solving for the aluminum will give you a 3+ charge, as you would predict. The oxygen is a 2, and the hydrogen is a 1, 2- and a 1+ respectively. Now, H2 is an element in its standard state. And if an element is in its standard state, just like on the aluminum, it is a 0 charge. Now what I need to do is find the two elements of which change in oxidation number. And the first one there is the aluminum. That is going from a 0 to a 3+. That's an increase in oxidation number. That's why this is oxidation. Then we have the hydrogen going from a 1+ to a 0. That's a reduction in the oxidation number. That is a reduction half reaction. Now what we're going to do is we're going to divide this up into 2 half reactions, and this is the first half reaction, which is the oxidation half reaction. Here is the second half reaction, which is the reduction half reaction. So in the first half reaction that I have written down there, we're going to balance all non-hydrogen, non-oxygen elements first. There's 1 aluminum, 1 aluminum. Those are balanced. Then I'm going to balance the oxygens and the hydrogens. Now, this is a very special case here of an equation here, and this one is also in a basic solution, just like the balancing equations number 8. Okay, knowing that it's in a basic solution, I know that I'm going to have a hydroxide ion on the reactant or product side in some capacity. Okay, now you can balance the oxygens like we've done before by adding 4 water molecules to the reactant side and then adding hydrogens respectively so that they are balanced as well, and then canceling those out. Now the other thing that you can do is you notice that there's OH and there are 4 of them. So we can actually use that OH and 4 of them and just add it to the reactant side like this, knowing that this is in a basic solution. Now, I have a net charge of 4- on the reactant side and a net charge of a 1- on the product side. You always go towards the lower charge, which in this case is a 4- charge on the reactant side. So I'm going to have to add 3 electrons to the product side like that. Now I have a net charge of 4- on both sides. Fantastic. Now we're going to move on to the reduction half reaction. Okay. Remember, you're going to balance all non-oxygen, non-hydrogens first. We only have oxygens and hydrogens, so let's balance the oxygens. On the reactant side, I have 1 oxygen. On the product side, I don't have any oxygen, so I'm going to have to add an equivalent number of water molecules to the product side, which would be 1. Right there like that. Now, I'm going to balance the hydrogens. How many hydrogens do I have on the reactant side? 2. How many hydrogens do I have on the product side? 2 plus 2, that's a total of 4. There's an additional 2 hydrogens on the product side compared to the reactant side. So I'm going to add 2 hydrogen ions to the reactant side. Okay, all right, now that we've done that. Now, before we start balancing for charge, we do know that this is in a basic solution. And if it's in a basic solution, then I add an equivalent number of hydroxides as there are hydrogen ions, but to both sides. So I have 2 hydrogen ions on the reactant side. I'm going to add 2 hydroxides to that same side. In addition to that, I'm going to add 2 hydroxides to the product side. Okay? On the reactant side, for a hydroxide and a hydrogen, the combination of those two is a water molecule. So if I have two hydroxides and two hydrogen ions, that's two water molecules. So I'm going to cross out the two hydroxides and two hydrogens just like that. And now I'm going to reform that and put that into two water molecules on that same reactant side. Okay, I realized that there was already a water molecule on the reactant side. You could have put a 3 stoichiometric coefficient in front of that, and that would have worked perfectly fine. But I did want to separate that out just so that you see where everything is coming. Now what we need to do is balance this for charge. On the reactant side, I have a net charge of 0. On the product side, I have a net charge of a 2 minus. So I need 2 electrons on the reactant side to balance for charge, and I've done that right there. Now you should see that I have 3 electrons on the oxidation half reaction and 2 electrons on the reduction half reaction. They are on opposite sides. That is a plus, but they are not of the same number of electrons. So I'm going to have to multiply with a coefficient and distribute it out of a 2 coefficient on the oxidation reaction. That is right there. And then I'm going to have to multiply the lower reduction half reaction by a 3. Okay. I also included in this that there are additional excess hydroxide ions. That makes that this solution is in a basic solution, as I afore noted there. Okay. All right, so now what we're going to do is we're going to distribute that 2 on the oxidation half reaction and distribute the 3 on the reduction half reaction here. And so I'm going to get this for the oxidation half reaction. I've distributed out that 2. Then I'm going to distribute out that 3. I'm going to get this for the reduction half reaction. Remember, you're going to keep those arrows separating the reactants from the products in a vertical column. That will be an easy way to separate things out. Now what I want to do is draw a line in the sand, and I want to cancel things out. But before I do that, and the reason that I multiplied by the 2 and the 3 respectively is so that I can cancel out the electrons, of which there are 6. And that's on opposite sides. So the electrons cancel out. Okay, are there any other things that are similar on opposite sides or on the same side that I can combine? And yes, there are. There are hydroxides. They're on opposite sides. So there are 8 hydroxides on the reactant side and 6 on the product side. So there's going to be a net 2 hydroxides on the reactant side. There's also something else that's similar, and those are the water molecules. Okay, I have a net, I have a total of 9 waters on the reactant side and a total of 3 waters on the product side. So I will have a net of 6 waters on the reactant side. So nothing else is similar, nothing else can be canceled or combined, so I'm going to drop all these things down here, but reducing the hydroxides and the waters as is appropriate. And then this is what I get. So I have 2 hydroxide ions plus 6 water molecules plus 2 aluminums produces 2 hydrogens plus 2 aluminum hydroxide complex ion of a 1 minus charge. And again, every single time that you balance these redox equations, you want to make sure by double checking that it is balanced. So pay attention to this. So for the number of oxygens, I have 2 oxygens plus 6. That's a total of 8 oxygens on the reactant side. On the product side, I have 2 times 4 oxygens. That's 8. So the oxygens are balanced. On the reactant side, the number of hydrogens, I have 2 plus 6 times 2, which is 12, plus the additional 2, that's 14. Okay, so 14 hydrogens on the reactant side. On the product side, I have 3 times 2, that's 6, and 2 times 4, that's 8. 6 plus 8, that's 14 also, so there are 14 hydrogens on both reactant and product side. Okay, now there are 2 aluminums on the reactant side, 2 aluminums on the product side. This equation is balanced, and I'm ready to label it. Okay, and that is what is undergoing reduction. What is undergoing reduction is that hydrogen, but specifically it's in the water. It's also the oxidizing agent. And what is undergoing oxidation? That is the aluminum, and it is the reducing agent. Remember, reduction and oxidizing agent, pretty much the same interchangeable terms, as well as oxidation and reducing agent, interchangeable terms. You are only labeling reactants on this. You are never labeling products. Products can never be the oxidizing agent or the reducing agent or undergoing reduction or undergoing oxidation. Okay, that was another problem balancing a redox equation in a basic solution, and you should see that there are excess hydroxide ions here on the reactant side. And again, these equations that you balance in either acid or base are extremely complex, so much so that you cannot balance them by the previous method of balancing of reactions way back a long time ago. Okay, there's no way that you would be able to come up with 2 hydroxides and the 6 waters on the reactant side by trying to balance this. It's just, I mean, you would spend all day doing that. Okay, I'm hoping that you enjoyed that video. If you did, make sure that you give me a thumbs up. I am the king of chemistry, so I'm crowned with the king. Okay, so if you enjoyed that video, give me a thumbs up. If you like the hat, give me a thumbs up. Please subscribe to my YouTube channel. If you know of anybody that needs help in chemistry, then please relay my YouTube videos to them. I would greatly appreciate that. As well as you can get yourself a cool merchandise here of a sticker or a t-shirt. Merchandise. Bam! I'll see you next time. Bye for now.